Alright, we're going to continue with this. We got some more factoring to do. So this next one, I'll just write out the name of it, then we'll show you how to do it. It's the difference of two squares. So last thing we did was perfect squares. This is a little different. This is the difference of two squares. They almost look like it's a perfect square. Now you might even recognize this. We talked when we did multiplication before, when we did the FOIL method, we actually did one of these, and I think I might have even alluded to the fact that we were going to go backwards at some point, and here we are. We're at that point. We're actually going to go backwards. So let me do let's do this. What if I had x plus 5 times x minus 5? Now let's just go through the whole FOIL method. We'll do a couple of these and just kind of establish a little pattern, because these are actually really simple. They really are. It's not a perfect square, is it? Remember, if it was a perfect square, both of these would be exactly the same, but they're not exactly the same. One's a positive and one's a negative, but all the other stuff is the same. Alright, so let's go ahead and FOIL it. So x times x is x squared. And then the outside is minus 5x. The inside is positive 5x, or plus 5x. And then the last is minus 25. Alright, and then we work this thing out. X squared. Look, those add up to 0, or cancel out, a lot of people say. And it's minus 25, and that's your answer. Okay, that's pretty easy, isn't it? So look what happened to the outside and the inside. They just added up to 0, didn't they? So really, if you recognize this, if you see one is plus and one is minus and everything else is exactly the same, really all you got to do is multiply the first and the last, because you know the outside and inside are going to add up to 0. So let's do another one. Let's go x plus 7, x minus 7. Let's do this without going through the whole FOIL method. We recognize it, don't we? Look at it. They're both the same, except one's plus and one's minus, so we recognize what we should do. We know the outside and inside are going to add up to be 0, so all we have to do is the first and the last. So if I multiply the first together, I get x squared. If I multiply the last together, I get a minus 49. Pretty easy, isn't it? But this is not factoring. This is multiplication. We've actually done this before. Okay? And this is probably, what, the third or fourth time we've done this. So I always start off with a multiplication, get an answer, and then I say what? Let's take the answer and figure out how we get back to that question. Right? It's kind of like backwards multiplication, or a lot of people call this backwards FOIL method. Alright, so what we're going to do is we're going to start with this answer, and we want to figure out what are the factors of this. What two things are being multiplied together to get this thing right here. Does that make sense what we're doing? Alright, you see a pattern, right? I've been doing this over and over again. You should be following along a little bit what I've been doing here. So let's take a look at this. First of all, let's look at the name. I think the name is very important. Look, the difference of two what? Squares. Now look at this. Do you see a difference in this answer right here? What's indicated by the difference here? The minus. Good. Okay, the minus means it's the difference, okay? Because subtraction, the answer to a subtraction problem is the difference. Remember that? Okay, so there's the difference, the minus, of two squares. Well, look at this. Is something being squared to give you x squared?
Yeah.
What is it? X. Is there something being squared to give you 25? Yeah, there is. Okay, it's what? It's 5. Good. And it makes sense, doesn't it? Because look, remember, these numbers are exactly the same except for the signs, right? So the first one is the same exact number. So if I multiply something by itself, you're squaring it, correct? And the last one is the same exact number. So if I multiply it by itself, I'm squaring it. And that's how I get to 25. So what we're trying to do is we're trying to look at this and go backwards. It's just a matter of recognizing it. Look at it. Is it a difference of two squares? Absolutely. There's a difference. Something's being squared to give you this. Something's being squared to give you this. Then we can write it just like this. Same thing here. Look, difference of two squares. Is something being squared to give you 49? Yes, yeah. 7 is. Is something being squared to give you x squared? Yep, it's x. And so you put, look, you write two parentheses. I always do this. I always start with the signs. One is always positive, one is always negative. Notice on both of these. I mean, I could do 2 or 3 more examples if I wanted to, just to kind of establish this pattern a little bit. Malachi, you getting all this? Okay. So make sure that you recognize there's a difference of two squares, and then you can factor it very, very easily. I really believe, and you may say that, and I've been accused of this many times, Mr. Hammer, you always say this is very easy. Okay, but this one is actually one of the easier factorings that you're going to do. I promise you. All right, some are a little tougher. This one's probably one of the easier ones to recognize. So let's just do another easy one, and then we'll make it a little bit tougher. Okay, we don't want them this easy, do we? What if you had this and I asked you to factor this thing right here? First of all, let's look at it. Is it a perfect square? Is there a greatest common factor? Is it a grouping problem? Okay, we got to figure out which one of these is this type of problem. No, what is it? It's a what? Difference of two squares. That's right. So recognize it's the difference of two squares, and you should recognize what to do if it is a difference of two squares. You do the two parentheses, one's plus and one's minus. That's the first thing I do every single time with one of these. Everybody writing this down? All right, and then so, what is being squared to give you x squared? An x. So that goes here and it goes here. Remember, everything's exactly the same except for the plus and the minus. What's being squared to give you 64? 8. So I put an 8 here, 8 here. See? I wasn't lying. It's pretty easy, isn't it? Make sense? Yeah, I think that's pretty good. All right. Now they're gonna jazz it up a little bit. All right. So let me find a good one. This is not much more difficult, but a little bit. Not much. All right. Look at this. We're gonna factor. I don't have to write factor every single time. I want to factor this. Let's take a look at it. Is it one of those things we've been talking about? Is it a difference of two squares? Absolutely. Yes. There's the difference. Are you squaring something to get this? Yep. What are you squaring? 2m. And this? 3. So what do? You put two sets of parentheses. One is plus, one is minus. Okay? I would do that every time. I think it's easy to set it up like that. And then, you just told me, 2m goes here and 3 goes here. The other parentheses is exactly the same except it's a minus. And there you go. You factored it. Am I right? It's easy, isn't it? Okay? Good. Let's do it. Let's switch it up just a little bit. Alright, look at that crazy thing. Alright, so you see the minus. The very first thing I do, as soon as I see two terms and a minus, I'm thinking difference of two squares. So let's just make sure it is. Make sure it's a difference of two squares. Alright, so there's the difference. Is there something being squared to give you this whole thing right here? A minus 2b. Exactly right. See, it's being squared right here. Is there something being squared to give you this? Yep, 2 what? C. And that's, if you can recognize that, you can do this problem. It's that easy. I'll make these parentheses a little bit longer because I got to put an a minus 2b in here. So I'll put my two parentheses, one's plus, one's minus. Okay, in the first term, what's being squared to give you this? A minus 2b. And I'm going to put it right here as well. And then what's being squared to give you 4c squared? A 2c, right? Because 2c times 2c has to equal 4c squared. And there you go. That's it. Can't do anything else with that, right? There's no like terms. Can't do anything. And there's your answer right there. Pretty cool. I like this one, don't you? Yes, Mr. Hamrick. I do. Alright, oh, this one's a little tricky. Alright, this one's a little tough. So we got to recognize it a little bit. Minus x squared. See, I didn't say everything was easy, did I? I said this was a little tough. Look at this. Now this is a little bit different, okay? You're gonna have to think more than just difference of two squares. First of all, it's not just two things that are being subtracted, is it? I've got four things right here. So let's take a look. Can we do this by grouping? Probably not, because, well, maybe in a sense we can. I mean, you could probably group the x squared and the 6x together, but, and maybe you could, the y squared and the minus 9. I'm thinking maybe of doing it a different way than they did it. Because I was just thinking of grouping here. I'll tell you what. Do you mind if I do it two different ways? Is that alright? Because I know some people don't like that because they want to see it one way and I want to memorize that way to do it. But let's think outside the box a little bit, okay? Now I don't even know if this is going to work. I just saw it and thought of it because I said grouping, right? And so I'm thinking of grouping. So I'm thinking, I might be able to group the x's together. And look at the y squared, the minus 9. That's a difference of two squares, isn't it? So I could probably put those together. So let's see. So let's group this and this. All right. So negative. Let's just kind of put them in order. negative x squared plus 6x, and then do whatever you want to do. So there's y squared minus 9. This might be a better way to do it. I would. If I was a student and a teacher said, I'm going to show you 2 ways to do it, I'd write both ways down. Because I might well, you got to get beyond being confused. I mean, sometimes there's 2 ways to do things. And sometimes you need to know both ways to do things. Alright? So I know it's a little more confusing, but that's alright. There's nothing wrong with that. I've been confused a million times in my life. You just have to overcome it. So let's take a look at this. Minus x squared. I don't like that minus. So maybe I'll do this. Maybe I'll go x. I'll just factor out a minus from this just to make it look a little bit easier. And I don't know if this is going to work or not. Again, what did I say? I said I just saw this and I thought maybe I'll give it a shot. And I'm not just messing around. It's not just teacher talk. Sometimes teachers say, oh, I don't know what to do. And they know what to do, right? I do that myself quite a bit. But on this one, I really am not quite sure if I'm going to go this route or not. But let's see. Oh, you know what I could have done? I could have factored out that x right away, couldn't I? Alright, let's just do it like this for right now. And then I'll just go one step at a time here. Look, I got an x in common with this, don't I? So I'll factor out yeah, let's do it like this. Plus, let's go ahead and factor this. I might as well do it now. Y squared minus 9. You know what that's going to be, right? It's a difference of 2 squares. We put a y here, put a y here, put a 3 here, and a 3 here. And again, we may just scrap this method. And the more I do this, the more I'm thinking about scrapping it. But that's all right. It's always worth a shot. Because you never, it's not like you always think of the right way to do it the first time every single time. So, let's see what I want to do. Yeah, I don't think I'm liking this way. I think this is kind of a dumb way to do it. Yeah, I'm seeing what the answer is, seeing how I can manipulate this a little bit to make it look like we want it to look. I mean, I definitely like the way that they do it, but I just thought that maybe this would work. Oh, I'm looking at the wrong problem. Hold on. Yeah, I'm not liking this. Forget this. And that's alright. Look, I got no problem with that. Alright, because sometimes that happens, doesn't it? You don't always look at a problem and go about it the correct way, do you? Okay? So I think it's fine for you to see me actually trying it one way and then not coming up with a solution. I don't think that's a problem at all. I mean, I would have liked this to work out, and maybe there is another way to work this out a little bit better, but I came up with a roadblock, and that's okay, because you would do the same thing sometimes, right? You start a problem, you start it a certain way, and you're like, wait a minute, I'm not getting anything good out of this. There's got to be a better way, and so you try another way, right? That's what math is about. All right, I don't always look at a problem and know how to exactly do it. So let's try it a different way. So let's write the same problem down. Now what I'm going to do is this. You got to be careful though. Let's do this. Do you see the x squared, 6x, and 9? Do you recognize? That kind of looks like something, doesn't it? Remember, if you take half of the middle one and square it and get the last one, what kind of a factoring is that? It was the last thing we did. We did on Friday. It's a perfect square, isn't it? Okay. So this is actually a perfect square right here. All right. So that's what we should have, and I should have seen that right off the bat, and I didn't, and that's okay. Again, sometimes I don't see it the right way right off the bat, and I'm sure if I didn't see it the right way, you might have not seen it the right way. Okay, so let's do this. But you got to be careful with this. Do you see this minus out here? I can't just put a parentheses around this. Do you understand why? Because if I just stuck a parentheses right here, remember this was a plus 6, but if I put a parentheses there, what is that minus doing to this? It's making it a minus 6, isn't it? So if I'm going to keep this minus right here, now that's fine, I can do that because that was a minus x squared, wasn't it? But now, what's this going to have to be, though? It's going to have to be a minus 6x. Do you see that? And what's this going to have to be? It's going to have to be a plus 9. Now, I'm going to get rid of this parentheses because it's not really... Okay? So now, look. Is this the same as this? Yeah, because if I distribute a negative, it's a negative x squared, it's a positive 6x, and it's a minus 9, just like that is. So if I put parentheses around it, I got a minus sign out front. You got to be very, very careful about this. So this is the same as this, except I forgot the squared here. Now, let's take a look at this. We said that this thing right here is a perfect square. So let's write it as a perfect square. Remember how we do this? We did this on Friday. Go back and look at the video from Friday if you forget how to do this, because we taught it Friday. So remember, if I take half of this, which is 3, and I square it, I get 9. So that means this is a perfect square, right? So I put minus what? 3, and then a squared right there. Always take the sign, that always goes right here. Take the square root of that, and it's 3. Now I got a perfect square. So on this problem, it wasn't just a one-step problem where you had a difference of two squares. You had to do the perfect square thing first. Now look at it. Do you recognize it now? Now you have a difference of two squares. Now we can go ahead and factor it the way that we taught you today. All right, so there's a plus here, minus here. There's a y, and then an x minus 3. Now you got to be careful with this one right here. See that minus? So let's give myself a little more room. If I have a minus out in front, it's very important that you put that x minus 3 in parentheses. So there's a couple little tricks that you got to be aware of, and you got to think of how your numbers work. I can't just put minus x minus 3, right? Because what is it? It's minus x, what's that? I got to distribute that negative through there. It'd be a plus 3. So let's write this out a little bit nicer. Y plus x minus 3. I can't really do anything with that. But if I distribute this negative through, I would get y minus x plus 3. That is completely factored. I told you it was a little trickier than the other ones, didn't I? Wasn't lying. But hopefully you've written that down and you see. You look at it, you recognize, hey, perfect square. But there's 2 times you had to do this. You had to factor out a negative from this before you put it in parentheses. That was very, very important. Hopefully you see when you distribute, you do get the same thing as you did up here. But you had to realize to take out that negative and change the signs in here to begin with. Okay, that was a part that a lot of people forget or don't realize in the first place. So again, go back to the video, watch it, do the problem a couple times to make sure you know how to do that. Now, the difference of two squares, that's the easy part. This part right here might have been a little confusing. Since you had a minus here, you had to put that x minus 3 in parentheses, because it's y minus x plus 3 right here. Now it's completely factored and you're done. That was a little bit tough. Alright. Again, go back on it. I'll tell you what, there's one more. I skipped an example. Let's go back to it. It's very similar to what we just did right here. So it'd be good to do this one more time. Kind of looks the same. It's not quite though. Alright, so let's do it one more time. Hope you guys are awake and watching. Hope you're awake. Oh, that's y to the 4th. That's a little different. Make sure I wrote it down right. Okay, yep. Okay, let's take a look. The first part's actually a little easier than what we did on the last lesson, because look, you don't have a minus in front of that x squared, so if you look at this, that looks familiar, doesn't it? It's that perfect square thing again. Alright, so we got to factor it. So let's do that. Factor this, it's going to be x minus 3. We did that in the last problem. If you're not sure about perfect squares, go back to Friday's lesson and watch it again. But look at this thing right here. It's y to the 4th. We hadn't seen y to the 4th before. But you do have a minus. You do have something squared here. Can you write this as something squared? Y squared squared, right? That's y squared what? Squared. Now, why in the world would I want to do that? Because I want to make it look like what? A difference of two squares. Exactly right. Okay, so I want to make this a difference of two squares. So when I saw y to the 4th, I'm like, okay, wait a minute. I can square something. I can square y squared, right? Y squared squared is y to the 4th. Now, it's set up nice and easy for us, okay? So now it's a difference of two squares. So what do? I put two sets of parentheses, put a plus in one, put a minus in the other, and then just stick whatever this is right here. So it's x minus 3 goes here, x minus 3 goes here, and then a y squared goes right here, and a y squared goes right here, and then I'm done. So that one was just a little bit easier than the one we did earlier because I skipped it, not for a reason, just because I looked over it. That was a little bit easier. So there you go. You got two of those types where you had a perfect square, then you had a difference of two squares. You're going to see that every once in a while. It's not always going to be just one step and you're done. You know, greatest common factor, that's all you do. Perfect square, that's all you do. Grouping, that's all you do. You may have several different methods all in one to factor something. Okay? All right. Okay, let's do another type. This type we're going to do right here. If you can memorize this little formula, I guess if you want to call it, you should be able to factor these. It looks complicated at first. Alright, so I'll warn you, it looks like, oh my goodness, I'll never be able to do that. But all you got to do is memorize a little formula, you kind of get used to it, and then you just basically plug stuff in. And it's actually not as bad as it initially looks. So this is called, it's not the difference of two squares, it's actually the difference, actually, it doesn't matter what order we put it in, but I'll do it like this. It's the sum and the difference, not of two squares, but of two cubes. So if it's cubes, it's being taken to what power? To the third power, that's right. So the sum and difference. Let me just show you the little formulas. Remember I said you got to write a little formula down? This is it. We'll use A and B to represent this. So first of all, we'll do the sum. Now if you look at this, we actually have two formulas. But I'm going to show you a nice easy way to remember this because both formulas are almost exactly the same. So it's not like they're two completely different formulas, and that's kind of nice. There's just slight differences with the signs, that's all. So here's the situation. Actually, I lied. It would be like this. Let me write this just a little bit differently. Sorry about that. So it would be a cubed plus b cubed. Let's write it like that. That's better. Sorry. So this is a sum of what? Two cubes. Do you see it? There's the sum because it's a plus. This thing is being cubed. This thing is being cubed. If you have something that's in this situation, all you got to do is memorize this little formula, plug the numbers in, and you'll be good to go. So here's the little formula that you need to memorize. There's two parentheses. Now the first parentheses has two things in it. The second parentheses has three things in it. So I'm going to make the second parentheses just a little bit longer. All right? Everybody writing this down? Okay, write it down. I'll keep you awake. Norval, help me out. Write some stuff down. Are you writing this down? That'll keep you awake. Come on. I want to see your hand moving. I don't think you wrote this because your eyes were closed when I was writing all this stuff. You did it in your with your eyes closed. That was pretty talented. Now what we're going to do is we're going to do some signs. Now here's what I did. The first sign in here, there's going to be two terms in here, so there's one sign in here. The first sign is always going to be the same sign as this. All right? And I'll put a little S over here because it's just a little easy way to remember it. That's the same sign. Then you got two signs here because you got three different terms here, okay? So you got two different signs. The second sign right here is always going to be the opposite sign of this. So that's positive, this is negative. Everybody with me so far? So I've got same, I've got opposite, and then I got one more sign in here. This sign right here is always going to be positive. All right? So I just remember SOP. Doesn't really, you know, I don't have any like fancy thing to remember it like My Dear Aunt Sally or anything like that. I guess we could make something up. But just remember SOP. Some people just say SOP, but I just say SOP. Same, opposite, positive. Everybody see that? Okay, that's how you remember it. If you want to do the difference of two cubes, it's the same formula. It's the same exact formula as this, but the signs are going to be a little bit different. All right, it's still going to be same, opposite, positive. So look at this. If it was a cubed minus b cubed, you set it up exactly the same way. And I'll tell you what numbers to put in there in a second. But for right now, let's just understand this. So this is same, opposite, positive. So it's the same sign as this. So what's this going to be? Minus. This is always opposite this sign, so this is going to be positive. And then the last one's always going to be positive. Now some people say they memorize plus minus plus or minus plus plus. I never ever could remember it that way. So I just remember same, opposite, positive. This is the same sign. The second one is the opposite sign. And the last one is always positive, no matter what. Okay? So just remember, same, opposite, positive. Now, what goes in here? Yeah, so watch this. This is what you have to memorize, okay? It's just a matter of memorizing it. Write it down. Have a pencil in your hand. You should be writing it down. So you put an A and a B right here. And you do that for both of them. Remember, both of these are exactly the same except for the signs are just a little bit different. All right? It's just these two are switched. That's the only thing different. Right here, I put an A squared here, and I put a B squared right there. All right? And then, inside of here, you just put an AB. So if you can remember that formula, you'll be good to go. It's the same for both, except for the signs are a little bit different. So put an A squared here, B squared here, put an AB right in the middle. Think you can remember that? Two parentheses, AB here. Then over here is kind of the same, but it's A squared, B squared on the ends. And in the middle, you put A times B. And there are your signs. It's the same sign, the opposite sign, always positive. Do you see that? Same sign as this, opposite sign of this, and this is always positive. And there you go. If you can do this, you can do the sum and difference of two cubes. Let's do a problem. What if I said x plus, I don't know, 5, or let's say x cubed plus 5 cubed. Well, what's 5 cubed? Tell you what, let's write it like this. I kind of gave you a hint. What if I asked you to factor this? Okay. Well, first of all, is it a difference of two squares? Is it a perfect square? Is there a greatest common factor? Can you group them? Any of the stuff that we've done before. Can you do any of that stuff with this right now? Nope. It doesn't fit any of those factoring problems. But it does fit what? The sum of two cubes. But you got to realize, you got to look at this 125 and realize, is something being cubed to give you 125? It's not always quite as easy to see as something being squared, is it? Because you don't use cubes as much as you use squares. But there is. All right, it's the same as x cubed plus, what did I say this was? 5 cubed. Because 125 is 5 cubed. If you can write it like that, oh, let's keep these little formulas up top here so we can see them. If you realize that this is this, then it's actually pretty easy to factor. So let's do this. Let's put our two parentheses. Remember, the second one's a little bit longer than the first one. I always do my signs first. It's always same, opposite, positive. Can you remember that? Same sign, opposite sign, positive. So what's this sign right here going to be? Plus. This sign right here is going to be minus, and this one's always going to be plus. Now, what do we put here? We put the A and the B here, whatever's being cubed. In this situation, what is my A? It's x. And what is the B? It's just a 5. It's not 125, it's just the 5. It's whatever is being cubed to give you that 125. So you put a 5 here. Everybody see that? Then I go over here. I always like to do the ends first. So if I go A and B, this one was what? A squared and B squared. So let's take the A and square it. That will give us x squared. Let's take the B, which is 5, and square that. So that is 5 squared, which is 25. Good. And now we take the A and the B, we multiply it, and we stick them in the middle. So it would be x times 5, or what's a better way to write it? 5x. Good. And there you go. It's factored. What do you think? Pretty good, huh? Yeah. That's all there is to it. So, I wasn't lying, right? If you can memorize this formula, it's really not that hard to put it in here. But you know they're not always going to be that easy, don't you? Alright, so let's try one maybe a little bit tougher than this. Let's go to a different color. I'm kind of tired of that one. Let's go to this light orange or whatever that is. Let me find a nice good one here. I won't go too tough. Alright, here we go. This is a little bit tougher, okay? Tell you what. Use a different number than they do in the book. Alright, there we go. Now again, you have to look at things and you have to understand if a number is being cubed or not. Look at 8. Is there something being cubed that gives you 8? Well, let's just think of the 8 right now. Forget the x. Just the 8. 2. Right. 2 cubed is 8, isn't it? Would you agree? 2 times 2 times 2 is 8. That's a number you need to recognize. So yeah, 2 is being cubed. What about this, though? This, some people have a hard time with. Is there something that's being cubed to give you x to the 6? So is there something that's being cubed that gives you x to the 6? Say it, Tiffany.
X squared?
X squared, that's right. Because look, x squared is being cubed, isn't it? Because this would be x to the 6. So what do we have? We got a 2, and we have what? X squared. And that is being cubed. That's the hardest part of doing this problem, is just understanding, is there something that's being cubed to give you this? Yeah, absolutely. 2 cubed is 8. X squared cubed is x to the 6. What about this one over here? What's being cubed to give you 27? 3. 3 cubed is 27. That's right. Is there something that's being cubed to give you x to the 9th? Watch. Is there something being cubed that will give you x to the 9th? X to the what? How about 3, right? Because remember the rule? Power taken to another power, you multiply them together. So that would be x cubed. So this would be 3x cubed, and that would be cubed. So that's what we have to do. Our very first step is make sure we write it as a sum or a difference of 2 cubes. I'll tell you what, just erase it. Put a minus right here instead of a plus, just to be different, right? Because we did plus earlier, didn't we? So let's just do minus just to be different. Now, what's our a and our b as far as our little formula goes? Right, that's our a, which is the 2x squared, and our b is now the 3x cubed. So really, we just set up our little formula. Put our parentheses down. Give it a little space because we got these are a little bit bigger. What's the first thing I do before I start sticking numbers in there? My signs, okay? And how do we know what signs? Remember, this is a minus now. So this is always going to be the what? The same, so it's going to be minus. This one's always opposite, so it's going to be plus. And this one's always going to be what? Positive. Everybody see that? It's easy to remember, isn't it? I just kind of came up with that on my own when I first started teaching this stuff. It's not in the book. Nobody told you, but to me, it makes me remember it. Same, opposite, positive. All right. What goes in here? A and B goes here, right? But what's our A? 2x squared. That's right. Don't put 8x to the 6 here. That's not what our A is. Remember, it's what is being cubed is what goes here. Same thing with this. 3x cubed. Now, let's be a little careful here. What do we do here? This is the A what? Squared. So this is my A, isn't it? So I have to take that and I got to square it and I got to put it here. We can do that in our head. It's 4x to the 4th. Okay, because I'm squaring 2x squared. Make sure you understand that. Put a little note there that explains it to you, whatever makes sense to you. Then I always go over here on the end and I do the B, the second one, and I got to square this one. So if I square 3, I get 9, and then x cubed squared is what? X to the, remember we multiply them, 6. Remember, if you take an exponent to another power, you multiply the exponents together. So that would be x to the 6. See, this is our a squared, and this is our b squared. That's probably the trickiest part of the whole thing after this part right here. Okay, from here to here is the biggest part, I think, of this whole problem. Right? But then that's probably, these two things are your second trickiest part to that problem. Now what do we do here? We just multiply the a and the b together. So we take this and this, multiply them together. So 2 times 3 is 6, and x squared times x cubed, know your rule. Right, know your rule. It's x squared times x cubed, you add the exponents together, so this would be x to the 5th. Alright? Takes a little thought. Alright, we're not doing pre-algebra anymore, are we? I mean, this is a little bit more involved than just doing a basic Algebra 1 problem. But after you get used to it, you'll feel it's just an Algebra 1 problem. And there you go, that's your answer. Now it's factored because you got this times this, and you're good to go. Alright, I'm going to give you a worksheet. And it says like 1,4b, I think, on it. On the top. And I don't think you're going to do all of them. You're just going to go to number 12. All right, so you're going 1 through 12. All right, and that's it.